Math Blast 30, Tuesday. I can identify prime and composite numbers. Look at the numbers below. Shade each number that is prime. A prime number is a number that has exactly two factors, 1 and the number itself. So for 66, I know that 1 and 66 are factors. If I can come up with any other factor of that number, then the number would be a composite number. Composite numbers are numbers that have more than two factors. Since 66 is an even number, I know that 2 is also a factor. Therefore, 66 is composite. 60, 1 and 60 are factors. But I also know that 10 is a factor of 60 because 60 ends in a 0, and any number that ends in a 0 has 5 and 10 as factors. 30, again, it ends in a 0, so I know that 10 is another factor other than 1 and 30, so that number would be composite. 99, 1 and 99 are factors, but I also know that 9 is a factor. 9 times 11 gives me 99. 23, 1 and 23 are factors. Now those are the only two factors for that number, so 23 is a prime number, and I will shade that one in. 11, 1 and 11 are factors. Again, those are the only two numbers that are factors of 11, so I'm going to shade that one in, for it is prime as well. Fill in the chart below with 4 different composite numbers that are between 30 and 40. Well, I know that composite numbers have more than two factors, and so the numbers between 30 and 40 would always have 1 and themselves as factors, but every even number greater than 2 is going to have that additional factor of 2. So let's go with 32, 34, 36, and 38. I can round to the nearest specified whole number. Round 219,837 to the nearest hundred. Show your work. It's important that I note that we are rounding to the nearest hundred. I'm going to show my work on a vertical number line. At the bottom of my vertical number line, I am going to note how many hundreds. If hundreds is my greatest unit, how many hundreds would make up my number? So I'm going to start at the left of my number with the greatest place values, and I'm going to go all the way to the hundreds. Because again, if hundreds is my greatest unit, then every other unit that's larger than hundreds will be decomposed to become hundreds. So we would have 2,198 hundredths. In standard form, that can be written as 219,800. If I had one more hundred, then I would have 2,199 hundredths. And in standard form, that's written as 219,900. Now the midpoint, the number that's right between 219,800 and 219,900 would be 219,850. That magic 5 there in the next unit gives us the midpoint. Now I need to place my number on the number line. 219,837, I'm going to say, should go about here. And now I can round my number because I know that any number that lies below the midpoint will round down, and numbers that are at or above the midpoint will round up. So our number is going to round to 219,800. I can understand decimal fractions. Write each fraction in decimal notation and each decimal in fraction notation. Then locate each number on the number line. So 2/10 is in fraction form. I'm going to write that in decimal form. 0.2. I need 2 in my tenths place. 3/10 in decimal form would be 0.3. And 0.7 is written or read as 7/10 because the 7 is sitting in the tenths place. So now as a fraction, I can write that as 7/10. Now I want to note those on the number line. I notice that each of my units that I'm dealing with is tenths. So I'm going to start at 0 and end my number line at 1, and I'm going to break that into 10 equal parts. I want to break the whole into units of tenths. So that's 10 equal parts in the whole. Now I can note where 2 tenths would be. If 0 is 0 tenths, then I have 1 tenth and 2 tenths. And I can write that as a decimal. And above my number line, I'm going to write it in fraction form. Now note that that is the same spot on the number line. I don't want to write my 2 tenths in decimal form and my 2 tenths in fraction form beside each other. I want to line them up, one on top, one on bottom of the number line, because it's that same exact spot, just written in a different form. 3 tenths would be right next to it. And then we have 4 tenths, 5 tenths, 6 tenths, and 7 tenths. So 7 tenths is going to be right here. And then I would have 8 tenths, 9 tenths, and 10 tenths would be right here at my 1 whole. All right, Tori says the following number sentence is true. Nate says it is false. Who is correct and why? 7 tenths is less than 2 tenths. Well, when I look on my number line, I can see that 7 tenths is here and 2 tenths is here. And I know that numbers on the left of the number line are less. So 2 tenths is actually less than 7 tenths. And 7 tenths is actually greater than 2 tenths. So 7 tenths is less than 2 tenths is a false statement. Who said that? Nate said it was false. So I'm going to say Nate is correct. Okay, so we want to say 7, we can say 7 tenths is greater than 2 tenths. And I could say 7 tenths is to the right of 2 tenths on a number line. And we know that numbers that are further to the right are more. They're greater. All right, let's go to the back side of this sheet. Determine the perimeter and area of the rectangle below. Well, the perimeter, there's this key word in perimeter, and I'm going to underline it there, rim. The perimeter is the distance around the figure. I'm going to start at one point, and I'm going to walk my way all the way around the rim of the figure, adding up all of those sides. So I have 4 centimeters, 7 centimeters. This side is not given to me, but I know that it is 4 centimeters because it's opposite the 4 centimeter side. And in a rectangle, opposite sides are equal. This side here is not given to me either, but I know that that is equal to 7 centimeters. Again, it's opposite the bottom side here. So now I can walk my way all the way around the rim, and I would have 4 centimeters plus 7 centimeters plus 4 centimeters plus 7 centimeters. And when I add all of those up, I get 22 centimeters. So the perimeter is 22 centimeters. Now the area are the square units that cover the two-dimensional surface there. And we learned back in 3rd grade that we can tile the figure. I could make 4 rows that have 7 columns. 4 rows of 7 would give me 28 squares inside of that figure. But I don't have to draw the rows and the columns. I could, but I don't have to because I know that that's the same thing as taking the length times the width. So that's going to be 4 centimeters times 7 centimeters, or 7 centimeters times 4 centimeters, however we want to rotate our figure. And so when I multiply that, the area is going to be 28 centimeters squared, or I can note that as 28 square centimeters. That's the same thing. I understand angles are measured with reference to a 360-degree circle with its center at the common endpoint of 2 rays. A circle measures 360 degrees. If the circle were divided into 4 equal parts, what would be the angle measure of each part? Explain how you know. So I'm first going to note the center point. And we want to break that into 4 sectors, 4 parts in the circle. So I'm going to break it in half, and then I'm going to break it in half again. And I know that the whole circle measures 360 degrees. And so if I equally share that 360 degrees among my 4 equal parts, well, that's the same thing as saying 36 tenths divided by 4 in unit form. And so I know that's equal to 36 divided by 4 is 9. And if that's tens, then it's 90. 90 degrees for each sector. I can determine the measurement of missing angles. Determine the measure of angle ABD. Well, I have here as my initial ray AB. It's lined up with the 0. And as angle BD here opens, then I can see it's past 30, but hasn't quite gotten to 40. Right in the middle of 30 and 40 is 35, and it looks like it's going about 1 more, maybe 2 more. So I would say 36 or 37 degrees would be pretty accurate in this case. Angle ABD is 36 degrees. It's an acute angle. I noticed that from the beginning. So I know that my measurement matches my angle type.